Module 4 Graphs and Relations. Use the following information to answer questions 1 and 2. The distance time graph below shows the train's journey between two towns. The train leaves the first town at 11 a.m. and arrives at the second town at 2 p.m. Question 1. What is the average speed of the train for the entire journey in kilometers per hour? We know that the average speed equals distance traveled divided by the time taken. From the graph, we look at the maximum point, and that is 180 kilometers divided by 3 because there are 3 hours between 11 a.m. and 2 p.m. and that is 60 kilometers per hour. So the answer we're after is option C. Question 2. For how many minutes was the train stationary during the entire journey? The train was stationary from 11:30 to 11:45, that is 15 minutes, and then from 12:45 to 1:15, that is 30 minutes. So 15 plus 30 equals 45 minutes. So the answer we're after is option D. Question 3. The graph below shows a straight line that passes through the points with coordinates 6 and 18 and 10 and 22. The question is asking to calculate the coordinates of the point where the line crosses the y-axis. Let's label this point with coordinates 0 and C. We are going to calculate the gradient of this line, which is 22 minus 18 divided by 10 minus 6, and that equals 1. We can now write the equation of the line using the point with coordinates 6 and 18. That is, y minus 18 equals 1, the gradient, times x minus 6. Therefore, y equals x plus 12. So the value of c equals 12. So the coordinates of the point where the line crosses the y-axis is option B. Question 4. The graph below shows the cost in dollars of sending a package by a courier based on the weight of the package in kilograms. Gloria has to send 3 packages to 3 different destinations with the weights shown below. What is the total cost of sending all 3 packages? Let's start with a package of 1.5 kilograms. We go up on the graph until it meets the graph, and that is $13. The package that weighs 2 kilograms, now be careful here because we stop at the dot. The dot is part of the graph, so that is $18. And then the package weighing 4.5 kilograms, we go up and then across, and that is $24. So the total cost equals 13 plus 18 plus 24 equals $55. So the answer we're after is option E. Question 5. Wong's dishwasher repair business repairs dishwashers in owners' homes. If it takes 45 minutes to repair a dishwasher, the cost is $155. If it takes 2 hours to repair a dishwasher, the cost is $330. The rule for the cost of the repair service is given below, where A is the fixed fee for coming to the owner's home, B is the charge in dollars for each 15-minute unit of time required to repair the dishwasher, and N is the number of 15-minute units of time required to repair the dishwasher. The question is asking, using this rule, to calculate the cost for a 90-minute service. First, we are going to change the 45 minutes into 15-minute unit of time, that is 3, and the same for 2 hours, which is 120 minutes, that is 8 times 15 minutes. We can now write 2 equations using the information given as shown. We subtract equation 1 from equation 2, and that gives us 175 equals 5b. Therefore, b equals to 35. We substitute b equals 35 into equation 1, and we end up with a equals 50. So the equation for the cost is equal to 50 plus 35n. Now we want to calculate the cost for the 90-minute service. So 90 minutes equals 6 times 15 minutes. We substitute 6 into the equation of the cost. So we have 50 plus 35 times 6, that is equal to $260. So the answer we're after is option D. Question 6. The feasible region defined by 4 inequalities is shaded on the graph below. The question is asking which one of the inequalities given as options can be used to define this feasible region. First of all, we have the equation of the vertical lines. X is greater than or equal to 4 and x is less than or equal to 6. Now let's determine the equation of one of the lines. The gradient of the line that starts at y equals 4 has a gradient of negative a half and a y-intercept at 4. Therefore, the equation of this line is y equals negative a half x plus 4. We multiply the equation by 2 and we move the term in x to the left-hand side of the equation. So we have 2y plus x equals 8. For the feasible region, 2y plus x is greater than or equal to 8. Therefore, the answer we are after is option B. Question 7. A 1200-liter tank is being emptied by 2 pumps. After p minutes, when 800 liters has been removed, one of the pumps stops working. The graph below shows the volume of liquid, V liters, in the tank at time t minutes. The tank is empty after 29 minutes. If both pumps had continued to work, the tank would have emptied in 24 minutes. If we extend the first line intersects the horizontal axis at 24:0. Over the time interval from p minutes to 29 minutes, calculate the rate at which the tank is being emptied in liters per minute. Now let's label the points that we need with A, B, C, and D. If we calculate the gradient of AD, that is negative 1200 divided by 24, that is negative 50. The gradient of the line AB is the same as the gradient of the line AD. Therefore, negative 800 over P equals negative 50. Therefore, P is 800 divided by 50, which is 16. So the coordinates of B are 16 and 400. Therefore, we can now calculate the gradient of BC, which is 0 minus 400 divided by 29 minus 16. That is approximately negative 31. So the answer we are after is option D. Question 8. The feasible region for a linear programming problem is shaded on the graph below. The coordinates of the points that define the boundaries of the feasible region are P00, Q06, R35, S53, and T70. When maximizing the objective function z equals ax plus by, where a and b are positive, for these constraints, the solution is found at point R only. The question is asking for the values of a and b for this objective function. Let's start with option A. When a equals 1 and b equals 1, z equals x plus y. Therefore, z at point Q is 0 plus 6, which is 6. Z at point R is 3 plus 5, which is 8. and Z at point S is 5 plus 3, which is 8 as well. Now remember that the maximum should be at point R only. Therefore, we can cross out option A. Let's check option B. When A equals 1 and B equals 3, Z equals x plus 3y. Z at point Q is equal to 0 plus 18, which is 18, and Z at point R is 3 plus 15, and that is 18 as well. Therefore, we can cross out option B as well. Let's check option C. When A equals 2 and B equals 3, Z equals 2x plus 3y. Z at point Q equals 0 plus 18 equals 18. Z at point R equals 6 plus 15 equals 21. Z at point S equals 10 plus 9, which is 19. Z at point T equals 14 plus 0, which is 14. And Z at point P is equal to 0 plus 0, which is 0. Since they are all different, and the maximum occurs at point R only, the answer we are after is option C.